Try to imagine a new smell. Not a combination, like fresh-cut grass on a rainy day, but a truly new primary scent. It's difficult, perhaps impossible. Your mind might grasp for analogies, like the smell of a color, maybe the cool sharpness of blue, or the heavy warmth of red. But these are just cross-wirings of existing senses. This isn't a failure of imagination. It's a fundamental feature of how your sense of smell is constructed. Unlike light or sound, which exist on a continuous spectrum, smells are discrete. They are recognized, not perceived on a scale. Your olfactory system is less like an eye and more like a library of very specific keys. Deep inside your skull, the olfactory bulb acts as a biological sorting station. When you inhale, airborne molecules, called odorants, are drawn into your nasal cavity where they bind to olfactory receptor neurons. There are about 400 different types of these receptors in humans, each sensitive to specific molecular features. A single scent, like that of a rose, is not one molecule, but a complex cocktail of hundreds. The pattern of which receptors are activated by this cocktail is what your brain learns to recognize as rose. It's a combinational lock. To invent a new smell, you would need to activate a combination of receptors that has never been activated before. You'd need a key that has never existed. For decades, we assumed this lock-and-key mechanism was based purely on a molecule's shape. This is the shape theory of olfaction. But then a biophysicist named Luca Turin proposed something else, the vibration theory. He suggested that our receptors don't just detect shape, they detect the quantum vibrations of a molecule's atomic bonds. Different isotopes of the same molecule, which have the same shape but different vibrational frequencies, should, in theory, smell different. And experiments have shown they sometimes do. This suggests our nose is a tiny, incredibly sophisticated spectrometer. It's not just feeling the shape of the key, it's listening to its hum. So, if we can't imagine a new smell from scratch, how can we construct one? We can use language and memory as scaffolding. What is the smell of nostalgia? It doesn't exist as a molecule. Instead, your brain summons a constellation of other scents. The attic dust from your childhood home, the specific perfume a relative wore, the chalk dust of a classroom. This is cognitive scent creation. We are building an olfactory idea. Perfumers are masters of this. They don't bottle adventure. They combine notes of sea salt, damp earth, and distant wood smoke, a chord of existing smells that resonates with our stored concept of adventure. This is where our own biology hits a wall. But artificial intelligence does not have this limitation. Researchers are now training neural networks on massive databases of chemical structures and their corresponding human-rated smells. The AI learns the relationship between molecular structure and perceived odor. It can look at a molecule it has never seen before and predict, with surprising accuracy, what it would smell like. This allows for a completely new kind of invention. We can ask the AI to design a molecule from the ground up that has a desired scent profile, a molecule for a smell that may not exist anywhere in the known universe. This is olfactory composition. Instead of arranging musical notes, we are arranging atoms. An AI could compose a scent that is precisely halfway between a lemon and a rose, a feat of chemical engineering that nature has never bothered to produce. It could create a smell with no natural reference point at all, a truly alien aroma. Digital olfaction devices, or scent synthesizers, could then mix base chemicals to physically create this scent. You could, in essence, download and print a smell that was conceived by an artificial mind. This moves scent from the realm of discovery to the realm of pure design. Extrapolate this further. What if we could bypass molecules entirely? Direct neural stimulation of the olfactory bulb could allow us to experience any scent, real or imagined, without an external source. In such a world, scent could become a medium for information, a language. Instead of words, you could transmit the complex olfactory idea of a situation. Imagine conveying the entire emotional weight of a memory, the joy, the subtle sadness, the specific time of day, in a single complex burst of scent information. Communication would gain a layer of phenomenal depth we can currently only write poems about. This isn't just science fiction. It reveals a truth about how our senses define our reality. Your personal library of smells is unique. The scent of rain on hot asphalt might be comforting to you, but unpleasant to someone else, based entirely on your unique set of experiences and memories. Your reality is, in a small way, olfactorily different from everyone else's. There is no objective smell of asphalt, only your brain's interpretation of that specific molecular pattern. Every new smell you encounter physically changes you, forging new neural pathways, adding a new entry to your private sensory encyclopedia. You are building your reality one breath at a time.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.